All right, today we're going to be talking about is projectile falling objects, so the word problems, but this time we can use a calculator or Desmos, and I'm going to focus more on Desmos. So let's go ahead, let's get started. So we need to think about finding the key features on Desmos. So let's look at this first example. A small independent movie company determines that profit P for producing N DVDs of a recent movie. And here's your equation. So P is your Y, and then N is the number of DVDs or units, which would be your X, and we know that because of how it is here. P is a profit in thousands of dollars, and N is in thousands of units. So how many DVDs should the company produce to maximize the profit? So we said DVDs were the units. And since we have the keyword maximize, we know we're looking for the vertex. So when we go here, what we're going to do is we're going to go to Desmos, and you're going to type in this equation. Now you could do P, or you could do Y, or you could do N, or you could do X. So for my example, remember you're going to click the plus and then just type in your equation. Now instead of P, I wrote Y, and then instead of N, I wrote X, but whatever, just keep it consistent. So if you're going to write N, make sure you write N here also. So I typed in this equation, and then when you go and you press enter, it's going to give you the graph here. And then, oops, that was a horrible line. And then since we want to maximize, we're looking the DVDs, so that's going to be your X value for this. So when you're looking at your X value, don't forget your X is in thousands of units, so those are your DVDs. And it says 85, but it really means thousands. So it really means 85,000 DVDs. So if we're looking at the 128.5, you would make that into thousands by moving the decimal and have it go from there. So let's look here. And so in this case, it'd be 85,000 DVDs. Oops. Then we want to know what the maximum profit will be. So maximum what? So this is going to tell you, well, we already looked at it, maximum profit. So we're looking at the vertex for the Y value. And again, oops, I wrote the wrong number here. There you go. So this is going to be 1285, but remember we said to the thousands, so that's what your green for your vertex is, and then this is the profit in thousands of dollars. All right, so then I went through and I just answered that there. All right, so that's all you had to do is type it in. So now let's go ahead, let's look at number 2. A company manufactures copy machines. The unit cost C, which is the cost in dollars to make each copy machine, depends on the number of machines made. So this would be your Y value because it depends on whatever is being made. So that would be your X. So if X machines are made, then the unit cost is given by this function. Now again, we know we've got X for a value, so those Y equals. And then how many machines must be made to minimize the unit cost? So minimize is your vertex also, but just remember your graph's going to look like that instead. So we're going to take this and we're going to copy that or type it in. And if you notice here, I did C of X. We could have just made all this Y. It's fine as long as you've got the numbers correct and whatever is in here is what you have here. So I went ahead, I typed that in. And you're probably going to have to scroll up a lot to get to this point. And it wants to know how many machines must be made to minimize. Well, machines would be your X, and that's 140. But remember, oops, Your x is 140, which is the minimum for this. So that's pretty easy there. And then I want you to try number 3. Go ahead, type this in, and then answer the question. And then let's go ahead, let's look at number 4. The number of board feet in a 16-foot long tree is approximated by this model. And don't forget this part of the equation too, kind of got cut off there. Where F is the number of feet and D is the diameter of the log in inches. So now if you're not sure which one's which, look here. So notice D is your diameter. That's really your X value, and all of this is your Y value. So feet is a function of D. So let's look here. How many board feet are in a log with the diameter, so we're looking at our X, of 12 inches. So we're going to take this equation, and wherever we see 12 inches, because that's our X value, we're going to substitute that in. And then all you got to do, oops, is, there it goes. There, so you can look and you've got 85.7. So you can round it here, but this is all I did, was just enter it into the calculator. But you do have the decimal, so it should end up being 85.73 feet. All right, and then it wants to know what will, oh, sorry, I gave you that answer first. Okay, but this one should be here, which is 85.73. Okay, sorry, now this one is B, which I just showed you. So diameter minimum, which is vertex, so we want to go here. So we got our diameter, which is right here, which is your vertex. So diameter, vertex, is 0.85714, but we're going to round that to 0.857. And then that's all we need to do. So not too bad. This is a lot easier. It's just making sure you understand what you're looking for. All right, so what I want you to do is I want you to go ahead. You're going to type in this equation, answer these questions, and then you're going to type in this equation and answer these questions for 5 and 6. All right. And then here, I think that was it. All right. Oh, here we go. Okay, for number 4, this is what I wanted to show you. If you take away, notice there's nothing here. So if you take that away and you just have this part and you press enter, it's going to give you the answer too. So this is like a calculator that you can use. And I think that was all the ones I needed to show you for that. So let's go ahead. Sorry for the flipping. Here we go. That's what I went the wrong direction. Okay, so now we can look at projectile motion as it relates to where the object started and the force applied. So now we're going to start figuring out how to set up the equations based on the information it's given. So if an object is dropped, when is it at its highest point? So if it's dropped, it's when you're holding it and at the start. So you're going to look at the y-intercept. Now, if an object is thrown, where does it start? Well, it's going to start in your hand, and it's going to be above ground. So if an object is kicked, it's going to be on the ground. So if an object is dropped, does it have any force other than gravity affecting it? No. If an object is kicked, does it have any force other than gravity? Yes, because it's how hard you're kicking it. If an object is thrown, does it have any force other than gravity? Yes, because it depends on how hard you throw it. So now that you know this is your projectile motion equation. So if you notice, a lot of these have started off with the -16 as your a value, t squared, and for -16 in front of the t squared, that's just gravity. That's the force of gravity right there. So if you drop something, that's the force of gravity. VO is the initial velocity, so that's the force applied, and then h is the initial height. So initial velocity, initial height. So it looks like a O, you just say initial. And that looks like a 0, but it's just your initial because that means 0 at the starting point. All right, so now let's go ahead and let's look at these graphs and the information we can get from it. So right now we're looking at this equation, and it has all three terms because it's starting off of the ground and it has a force being applied to it. So in this case, it starts here at 64, and it has a force of 60 being applied. And if you look here, initial height 64, and the initial velocity or the force is 60, which is x here. So it's just interpreting what's happening. And then if it's dropped, you're going to see it with just the initial height. So this had the velocity and height. This one's just height. So, and we've got that. So there's no middle term because there's no force applied. So we're starting, this is the initial height, which is your C value. And again, remember, there's no velocity. So we leave that as 0. So we know our initial height is 150 and our velocity is 0. And then looking here, if it's kicked, we have gravity, the force applied, which is 90, and then it's on the ground, so the height is 0. So project is launched upward at a speed of 34 feet per second from a height of 129 feet. So remember, we're going to keep that negative 16t squared as your first term. And then, oops, I wrote x, should have wrote t. There you go. All right, so now that we've got that, so you can keep them as t or you can keep them as x, whichever you prefer. It doesn't matter, but. So t, or you could do x. All right, so here we've got negative 16 is gravity. The initial force or velocity is 34, and the initial height is 129. So that answers, and we want to know when does it hit the ground. Well, that's your x-intercept, so you can use Desmos for that and just plug it in and you'll figure out that it ends at that point. And what's the maximum height? Well, that's your vertex also. So your vertex, again, you're going to plug in this equation into Desmos, and then you're going to find when is its maximum. Well, that's the vertex. And then I just sketched a little graph here. So we want to know when is it going to be the same height as it was launched. So we want to know basically when is y equal 129. So if you again plug that into Desmos, and what I like to do, did I not have it? I guess not. Okay, sorry. I thought I had it graphed here. All right, so anyways, what you're going to do is when you put in this, you're going to plug this in also, and then you'll get a line, and you're going to see where it intersects. Where it intersects, that's your answer of 2.125. All right, and then from here, if a firecracker shot straight up from the ground, that's going to give you an initial height of 0 with the velocity of 92. That's going to be your B value. And then again, enter in this equation into Desmos, and you'll see the x-intercept is when it hits the ground. You'll see your maximum. What is the maximum? So the maximum height would be 132.25. When is your x? The maximum would be 2.875 seconds. And then you want to know when will it reach a height of 80 feet. So all you got to do is we know y equals 80. And it's actually going to be at a couple different spots. So again, we have our vertex here. We've got our y-intercept here. And we want to know when it's going to reach 80. So that could be here and here. All right, so it's pretty easy. Just plug it into Desmos and then look at the information to determine what it's going to tell you. All right, and then that one's a book dropped from the top of a 140-foot building. So your initial height should be 140. and then go ahead and write an equation and then type that into Desmos to figure out your information from there. All right, and then that is projectile motion with Desmos.